we are looking at Newton's laws of motion. So we have an overview video over here. Okay, what do you guys remember from Newton's law? How many laws are there? 3, right? So what are the laws? What is the fundamental idea of those laws? There are 3 laws. First, second, and the third. See guys, it's quite simple. In general, we can just put it in this way. So what happens when there is no force? What happens when there is a force? Then what happens to the object that is applying the force? Okay, so these are the 3 things that we are looking at. So first law is to do with when there is no force, how does an object behave? Second thing is talking about when a force is applied, how does an object behave? Right? Basically, this is a net force, positive net force. Net force is non-zero. So the question is, what happens to the object? Here, more than net force, no force, I should call it as when the net force is 0. Same thing, what happens to the object? Now, we also look into what happens to the object that is applying the force. The source, basically. Looking at the effect of source. What happens to the source once it applies that force? So this is the overview. So we have the 3 laws. So let's look at that. Now, first law is to do with law of inertia. Do you guys remember the word inertia? Inert. What is inert? Where have you heard the word inert? Inert gas. What does inert mean? That things does not change. That's the whole idea. Since we are talking about the first law wherein net force is 0, things does not change. And so we have the law, and it's called as law of inertia. Object at rest or in uniform motion, that is at a constant velocity, no change in direction and no change in speed, in an initial reference frame remains so unless acted upon by an unbalanced force. That's your law of inertia. Again guys, there are keywords like inertial reference frame that we studied in first law, one-dimensional motion. What does inertial reference frame mean? And you need to understand every aspect of the law over here because you are in 11th grade or higher grades basically, and your lower grades you understood in a very brief manner, but now you're using words like in a inertial reference frame, then we're talking about net force, so you need to understand all of those, right? So mathematically, now we're looking at the math. Say first law, it deals about the net force, right? Net force, this is nothing but your sum of all the forces should be equal to 0. Okay, so this represents net force, and if you guys are not aware of this symbol, it is, okay, put it over there. This is to do with sum. So this is sum of all the forces ranging from I 0 to n and all of that. So this representation comes, where do you guys use it? Statistics though, yes. I don't know before that where we use it. So in statistics you learn this. So if you guys want to understand this in detail, you have to go to statistics. Okay. So basically, so this is 0. Then we know that mass into acceleration. Acceleration is a vector quantity. So that in turn will be equal to 0. And we also know that let me continue with this. Or we can also tell that mass dV by dt is equal to 0. So mass m1s are m0s are, and then we can tell that if derivative of a value is 0, what does that mean? Means the value is a constant, right? This comes from the derivative topic, that is derivative of any constant with respect to time or whatever it is 0. So from that fact, we have velocity to be constant, and that's your first law. Okay, let's move on to the next law. Law of dynamics. Herein, the dynamic word, what does it tell? Things are not inert anymore. The net force applied to an object is directly proportional to its acceleration in an initial reference frame. The constant of proportionality is called the mass of the object. We write this algebraically as, okay. Sorry, I need to drink some water. Second law. Okay. So here we have the force, the net force, that is to be sum of all the other forces. And this entire thing is equal to your mass into acceleration. And we know that acceleration can be written as dv by dt. Okay, actually, why am I going towards that direction? So all of this is non-zero. Okay, so this is non-zero for now. We'll just stick to that. Then what do we have? Oh, okay, I kind of have briefly introduced an entity over here. So since this is a constant, as m is constant, I can rewrite this as, again guys, this is an overview, so don't think too much about all of this. We'll be doing it in detail. So what is mass into velocity? Yes, momentum. Okay, so momentum is also a vector quantity, and we have this representation. So second law talks about force and rate of change of momentum. The net force is equal to rate of change of momentum, or the momentum is given by the net force, where we introduce the momentum particle, that is, momentum of a particle given by small p, which is a product of m into v. Okay, so yeah, again, it's an overview. Don't worry about this. Finally, we have the law of reaction. So we had the law of inertia. Then the dynamics change. So that's why we call it as things change. It's not stationary anymore. That's why we call it as law of dynamics. Now we're talking about, okay, it's dynamic. That's true. Means there's a source and there is an effect, cause and effect. What happens to the source? That's your law of reaction. If object B exerts a force FAB, sorry, this is not how it's supposed to be. It's supposed to be subscript. AB is supposed to be subscript. On object A along a line connecting the two objects, then the object A exerts an equal and opposite reaction force, represented this way. So mathematically, what we're looking at is third law, the math, that is, we have F, say, Ij. See, in terms of magnitude, Fij and Fji will be equal. If you guys remember from your previous grades, if you apply a force, an equal and opposite force will be applied back. So that's what I'm writing. But when it comes to vectors, we need to talk about directional aspect also. And we put a negative sign indicating it is in opposite direction. This indicates equal magnitude. Again, guys, all of this is an introduction, and yeah, So when I rearrange all of this, what do I end up with? Fji plus Fij is equal to 0. Right? So that is the net force, or the forces are equal and opposite. This is another way of expressing that. Okay, this is just an overview again. So we are trying to recap what we have learned in the previous grades. So we have learned that there are three laws: law of inertia, law of dynamics, and law of reaction. Law of inertia has to do with when nothing is acting on an object. Law of dynamics has to do with when we act on the object, what happens to it. There will be change in velocity, and so we have a new term called as momentum that we get introduced to over here. All of this will be seen in detail. And finally, we have law of reaction, that is the what happens to the object that is putting the force, right? So you can just briefly write this. So we'll be studying about law of inertia in the next set of videos. Sorry, I forgot to show the math.